Good morning, my dear students. Today we are going to start with our next topic, that is the types of reaction. Now we have already learned the hints of these reactions from our previous videos, that we have learned about displacement reaction as well as we have learned about the double displacement reaction. So now today we are going to start and we are going to understand the basics of these reactions. We are going to understand the mechanisms of these reactions, means how these reactions even take place while following these different things. So see, first of all, we should see the mechanism of displacement reaction. We know in displacement reaction only a single thing will get displaced. For example, here it is not D, it is B. So here, for example, if B was combined with A, now what will happen? After that, this C will attack, and as a result this C will join here, but this B will get separated. So this is a simple form of the displacement reaction. Now we have three examples of displacement reaction. The first one is when we displace this copper from copper sulfate by iron. So what we are doing is basically, see what is there actually, that we have actually copper sulfate. Okay, now what we are doing is this copper, and we have here iron also. Now instead of this copper, this iron will come, so we will form this iron sulfate and this copper will get separated. Now here what is happening, copper is displaced by iron. So this is a type of a displacement reaction. Now you can see here that when displace copper from copper sulfate by iron, so now what is happening, you can see iron is in its solid form. Now here is copper sulfate. Now copper sulfate is of blue color, that's why I have colored it blue. It is of blue color and it is aqueous. Now what will happen is, as soon as after some time the reaction will take place, after a time what will happen is the whole solution will turn green color. Now why it is green? Because iron sulfate has formed. Iron sulfate's aqueous form is green in color. So we can say that if the solution is turned from blue to green, it means the displacement has taken place, that this blue copper sulfate has turned to the green iron sulfate, and we have formed a black type of precipitate. Means here we have this something black over here. Now this is the solid form of copper. The second reaction is when we displace this copper of copper sulfate by zinc. Now you should know that zinc is also more reactive than copper. Similarly, iron is also more reactive than copper. So we can say one thing very clearly, that more reactive will displace the less reactive. So here also we are doing the same thing, only the one which is more reactive will be displacing the less reactive thing. So here we have more reactive zinc, and here we have copper sulfate solution. You already know this is again blue colored. Now after a few time we will form colorless solution or something white color. So this will be now zinc sulfate, and then we have the copper solid form. Third is when we displace copper from CuCl2, that is cupric chloride, by lead. It shows that again lead is also more reactive than copper. Now these things can come, okay, these things which I have mentioned in the box can come in the exams directly, that give the reactivity or arrange them in the correct order, or you can be asked that which of the following is incorrect. Like if one where anything is given like this, then you know this is wrong, because copper is not more reactive than iron, then this option will be wrong. So like that thing the questions can come in the exam. So here we have the solid form of lead. When we add this in the copper sulfate aqueous form, after some time we will form lead chloride, which is aqueous, and then we will be having separated out the solid copper. So this is the basic step of the reaction. Now let us see the double displacement reaction. Now let us see the mechanism of how this double displacement reaction will take place. Now we have already learned that if we have these two compounds AB and we have the CD, now what happens is that this B will go to this C and this D will go to this A, means finally we will form this AD plus CB. So this is a type of displacement reaction. The products can vary. So here also instead of CB we can get BC. This is one and the same thing, okay. So now let us put these values under the following given reaction. This is AB, means Na2SO4, and here we have CD, we have BaCl2. Now what we have formed is we have formed two products. Now this Na2SO4 is known as sodium sulfate and this BaCl2 is known as barium chloride. On reacting them we got barium sulfate, means we know here that sodium had sulfate, but now barium had sulfate, means barium exchanged the sulfate of sodium and sodium exchanged the chloride of barium. So from Na2SO4 it turned to NaCl, and similarly from BaCl2 it turned to SO4. You see these anionic portions have been exchanged. So this is the thing. Now here there is one more thing, that NaCl is there and BaSO4 is there. So some solution will be made. Now this solution, in the test tube you will see that there is one thing which is separated out. You can see one thing is insoluble, one thing is soluble. So in this solution one thing will be wholly mixed. Now what thing will be mixed means the thing which you cannot see is NaCl because it is soluble, but this BaCl2 you can see as precipitate because it will be getting separated as it is insoluble salt. Now let us learn about the next heading, that is redox reaction. Now this is again an important, it is a type of new lesson only. We are going to start with new lesson. So this is a redox reaction. Now basically you need to understand the meaning of redox reaction, that what is the meaning of redox reaction. Now you see from this root word rid plus ox, which means rid stands for reduction and ox stands for oxidation. So any reaction where reduction and oxidation takes place is known as a redox reaction. But now what is reduction and what is oxidation? This thing we should learn firstly. So let us see these things, what is reduction and what is oxidation. Here you can see that the gain, what we are saying, gain of oxygen to an element means we are giving oxygen to an element which is more positive than the oxygen. Means what we are saying, a positive element is there. Now you know if the element is positive, it might be what? It might be metal. Now what we are doing is we are giving oxygen to this. So it means that now we are oxidizing the metal will be getting oxidized. Or it also means the loss of electrons. In other words, we can say that metal has lost some electrons, which shows that it has been oxidized. Suppose we had zinc. Now zinc has become Zn2+. So it means it has lost these 2 electrons. Now for this 2 electrons lost, who will come? So oxygen will come. So oxygen will attack here, O2 minus actually. So like that thing we can see here. The first reaction is twice of Cu plus O2 gives twice of CuO. Copper plus oxygen gives copper oxide. We have balanced this equation. Now here this copper oxide is of black color. You can see that we have added oxygen to this copper to form this. So we can say that copper has been oxidized because oxygen is added to copper. Similarly, magnesium plus oxygen gives magnesium oxide, means we have added oxygen to magnesium. Again it denotes that magnesium is oxidized. The next reaction is known as the reduction reaction. The reduction reaction means the gain of hydrogen to an element which is more negative than hydrogen. Now learn this term negative. Now what does it mean? It means that we have some electronegative element, we have some negative element. Now what we are going to do? We are going to add hydrogen to this negative element. It means that now negative element is reduced. It also means that if someone is gaining the electrons is also a type of a same thing. That is, that particular thing is getting reduced. Like we have something element which is actually 2+. Now we are giving it 2 electrons so that to neutralize this 2+, and now we convert it to E. This means that 2 electrons are given, means this element is now in reduced form. Now you see the example CuO plus H2 gives Cu plus H2O. You can see very easily one thing, that hydrogen is gained by whom? Hydrogen is gained by this oxygen to form water, means oxygen is getting reduced. We can easily say from here only. Who is getting reduced? The one who is getting hydrogen, and oxygen is getting hydrogen, so we can say that oxygen is reduced. When a more negative element is lost, it means reduction, and when a more positive element is lost, it means oxidation. Now these are the same things. Like if I say that a negative element gained hydrogen, it was reduced, but now if a negative element is losing oxygen, it is again reduced. Similarly, if a negative element is now losing hydrogen, it means it is oxidized, and if it is gaining hydrogen, I told you it is reduced. So similarly, when the more negative element is lost, suppose we have one element, I previously only told you that we have some positive element, and when we added oxygen to it, now oxygen was more negative, so it was oxidation. Now we are doing reversal, means we are removing the oxygen. Now what does this mean? It means that this element is undergoing reduction. It is equivalent to Adding hydrogen means if you are adding something positive, some positive element is added or some negative element is removed, it means one and the same, that is reduction. Similarly, when you add some positive element or when you remove some positive element or add some negative element, it means again oxidation. So these are the two things which are same. Now let us learn about the redox reaction. What does this redox reaction signify? Now redox reaction says that in nature, whenever we come to know that in nature never ever oxidation reduction takes place separately. Always this oxidation and reduction are accompanied together. Means wherever oxidation is taking place, similar at same place the reduction will also take place. So in nature only oxidation reduction is not taking place, it is a combination of two. For example, this twice of Mg plus O2 gives twice of MgO. Look here very carefully. You can see that Mg is gaining oxygen. You know oxygen is more electronegative. So this element is gaining oxygen, which means Mg is oxidized. Why? Because it is gaining oxygen. Similarly for oxygen, now I told you if more positive element is gained, that time it is gained, okay, not lost. That time again it is reduction. So for oxygen we have a positive element which it is getting, so means it is reduced. Always learn thing in mind, when we add some negative element to any particular atom, means we are oxidizing that, and when we are adding something very negative to that atom, very positive to that atom, means we are reducing. Think of this situation. Oxygen is getting something positive, so element is getting something positive, it means the oxygen is reduced. And magnesium is getting something negative, here element is getting something negative, it means it is oxidized. So magnesium is oxidized and oxygen is reduced. So magnesium gains negative element, so it is oxidation, and oxygen gains positive element, so it is reduction. Think of these other reactions also. See the reaction CuO plus H2 means copper oxide plus hydrogen gives copper plus water. Look for this oxygen first. Oxygen is getting hydrogen, means the element E, I already told you, if element E or atom is getting something very positive, it means it is reduced. And if this another atom is gaining something negative, it means it is oxidized. Here this oxygen is getting something positive, so the oxygen will be reduced. And hydrogen, since it is getting oxygen, means hydrogen is oxidized. Think of copper. What is happening to copper? Copper was having earlier negative thing with it, but now this negative thing is removed. So if negative thing is removed, see, when we added negative thing it was oxidation. Now if negative thing is removed, it means reduction. And similarly, if positive thing is removed, what will happen? It will be oxidation. For this copper, we have removed oxygen, means we have removed negative thing. It means if negative thing is removed, it is reduction. So copper will be reduced. Take the next example. Zinc oxide plus carbon gives zinc plus carbon monoxide. Think of this zinc. Zinc was having a negative element, but this negative element is removed, so means zinc is reduced. Think of this carbon. Carbon is afterwards getting something very negative. It means if negative element is added, the carbon is oxidized. Think of this oxygen. Oxygen is getting carbon. Carbon is positive, so it means oxygen is getting reduced. Similarly, MnO2 plus 4 times HCl gives MnCl2 plus twice of H2O plus Cl2. This can come in balancing also. MnO2. You see here, do you know who is more negative, chlorine or oxygen? So chlorine being more negative than oxygen, we can say that in this manganese we are adding chlorine, means it is oxidized. And similarly this hydrogen is getting less thing, so it will be reduced. And finally you can see these chlorine atoms, also chlorine is adding with chlorine only, so chlorine is also getting oxidized. So this is the basic step and this is the basic explanation. So that's all for the day. Thank you and have a nice day.